Alright, so this is lesson number 8, using noise maps with VDB. Okay, so before we move on to modifying and distorting noise maps, let's take a look at how to use noise maps with VDB, because that's going to be a major part of this entire series. Okay, so I'll just create a piece of geometry. So for those of you who don't know what VDB is, it's basically short for volume database. Primarily, you're converting your geometry into a volumetric object, and then you're modifying it with noise or whatever. And because it's not polygons, it's pretty much resolution free. So as much as your computer can handle, you can sort of up the resolution, and you can get that much detail. Okay, so that's the whole idea behind using noise with VDBs, because you can get some really detailed objects. Okay, so to get started, Houdini gives you a fair bunch of VDB tools. So I can just take, okay, let's do one thing. I'll just take a box. Okay, so I can take a box, and you can just take a VDB from Polygon and convert it to VDB. Okay, so that's pretty much it. Now, if you try to render this, it will render as a fog, because this won't render directly. So it can do two things. It can either create a distance VDB, which is more of a solid object, or you can create a fog VDB. We don't want a fog. Okay, even though you can, if you want to create clouds and stuff, you can use a fog VDB. Okay, a couple of things you want to do is make sure that you turn on fill interior. Okay, and the exterior band voxels is this bounding box you're seeing around it. This is useful because sometimes when you apply a noise map to this, it will try to expand the volume, and if it touches this bounding box, it will clip. Okay, so you'll actually get a hole in your volume. So depending on how much you want, you can sort of expand this out. I'll show you how this works once we start applying some noise maps to it. The voxel size is your resolution. Okay, so the lower this is, the more resolution you get. Okay, so I can keep this to 0.01. That will give you, see, that looks more detailed. But that also means it will take longer to calculate. So usually calculate it at a smaller resolution, or at a lower resolution. And then when you need the final result, you can just, up the, or lower the voxel size. Okay, so to get started, it's pretty simple. You can just apply a volume warp, and then you can start applying noise maps. Now, what the only change I make is that default inside the volume warp, it looks for density. Okay, if I just plug this in and you jump in, you'll see it looks for density. Okay, and our noise map, or our volume field is called surface. Okay, so you can do that. What I can do is I can take a bind export. I can take both. I'll need both, right? So I'll take a bind and I'll take a bind export. I can call them both surface and then work on those. Or a simpler option is just come into this VDB and call this density. That makes it easier. Okay, so then because density is a global variable that it already has, you don't need to do anything fancy. Okay, you don't need a bind and a bind export and any of those things. So the way it works is fairly simple. You just take a turbulent noise or whatever you want, and the rules are the same. Just take position. Now the thing is, you need to add a turbulent noise into your volume, and usually that can be a bit too much. So what I do is take a multiply constant in the middle and keep it to somewhere around 0.1. Okay, so start working at that value, and then you can up it depending on how much you want. Then take an add, and then you can just add it to this. So we can just connect that, and there you go. Okay, if I remove this, you notice that it eats up a little too much. Sometimes it might eat up so much that your geometry will disappear. Okay, so if your geometry disappears, don't worry. It just means that the amplitude was too much. So just apply, either lower the amplitude here, which is also fine. Okay, or just apply a multiply constant in the middle, and then you can just control it this way, which I prefer because it gives me an additional set of values. If you want to create a parameter for it, you can take a multiply node and then create a parameter, and then you'll be able to get SOP level control. But again, I don't want to do that for this, so it doesn't matter. Okay, now we can already see some clipping happening here. Like you can see, like, a little bit of voxels are missing. So like if I take this up, we'll start to, actually no, it's going inward, so it's fine. Okay, so what is the big advantage of doing noise on a VDB rather than doing like a noise on a geometry? Okay, so if I don't convert this, right, let's say if I take this, and what I'll do is I'll do a subdivide on this, call it open subdiv bilinear, which means it won't really like, it won't smoothen it, and I'll keep it to around 5, so I get like enough geometry. And I can take a mountain sop, which gives me displacement. Okay, so I can take a mountain sop and connect it, and you get this. So the difference between doing it on geometry and doing it on VDB is that this kind of stuff doesn't happen because it's volumetric data. You don't get polygons intersecting with each other and causing issues. With this, it always sort of remains smooth, and when you convert it to polygons, you'll get the result that you want to get. The other thing is, because it's sort of like 3-dimensional displacement, you can actually get holes in your geometry, which you won't get otherwise. Okay, so it does give you a lot of advantages overall. Okay, so a lot of it is fair, like going through the noise maps is not important. Okay, but a lot of it is fairly simple, right? Like if I take a fit range unclamped in the middle, and then I can just start to sort of expand it if I want. See, so now if I expand it too much, you'll start to notice this is starting to clip. Okay, so if you end up with this kind of a situation, see, where you're now starting to touch these borders, come up to the VDB, from polygons, and increase the exterior band voxels. So let's make this about 10, and there you go. See, now it's okay. So don't increase it too much, because the more you increase it, the more time it requires to calculate it, and the more memory it will eat. Okay, so don't take it up to like 50 or something, because that means that's how many voxels you have in your scene, and it will just be a waste. Okay, so just increase it, just enough that you get the detail that you want. Okay, so let's say if I keep it to 10, and we can just sort of compress it if we want. And let's say if you want to animate this, so this is actually very good for like organic modeling if you want to. Okay, so let's take a float to vector to animate this, and I'll connect time to, let's say, x-axis, and I can connect that to offset, and this should give me, see, there you go, so you have a nice little animated geometry or animated volume. And then if you want to convert this to geometry, just take a convert VDB, and we can convert it, okay, to polygons. So there you go. Now, again, this detail is very much dependent upon the resolution. So if I come, usually I keep it around, like depending on the size of the object, we'll get it down to 0.01. Okay, again, like the minute this happens, that means your exterior band voxels is a problem. Okay, so let's make this 20, and that should help. Okay, hold on a second. If it's not helping, just come down here and lower the multiplier, and there you go. See, so you get like, nice little detail on this. So this kind of, like, firstly, trying to model something like this is almost impossible. Like if I come down to a slightly lower amount, and let me just try to, so like if you want to do any kind of damage, or you want to make cheese or something like that, like this is really good for those things. But yeah, you get a level of detail that is almost impossible to get with like standard modeling. Okay, so let's change the type. Let's keep it to like original Perlin, and again, let's just that fit range is causing problems for us. Okay, sorry, let's just increase that and lower the multiplier. Yeah, okay. And we can increase the frequency a little bit. So you can actually get like a lot of nice results out of it. Okay, like even at like keeping it fairly smooth, and then let's say if we like lower the attenuation, see, so you can get some really interesting results overall. It's especially good if you want to do, as I said, like if you're doing like medical animation, this is pretty powerful for those kind of things. So yeah, the results are pretty interesting, like overall what you can do with it. Okay, so you can do like, whichever one you pick, you're going to get some interesting results. Okay, if you want to reverse it, we can put like another fit range in the middle and reverse it. So I can take a fit range, or you can try to do a complement, but that might cause issues. Like you can drop a complement in the middle. There you go, see. So a complement is like a 1 minus x, so it gives you that. But it doesn't give you any control. So it's better to put in like a fit range. Let's take a standard fit range. Okay, because that will give you like a little more options. So I can take a fit range and then I can do like in the destination you can reverse it, make it 1 and 0. And then if you want, we can try to, sort of. So what the fit range does is, because you can clamp it, you don't get the holes. Okay, like that if I do the same thing with the fit range unclamped, it keeps trying to expand it out, right? Like if I put a fit range unclamped and then if I reverse this, so this is fine, but then as I start to lower the value, see, it keeps trying to expand, which is not bad, but then eventually it reaches the border and causes problems. So if you want to like expand, then you use a fit range unclamped, and if you want to like flatten it out to the size of the box, then you use a fit range. So I can remove this, and if I put in like a fit range, see, so this is like, so if I want to create like a wall or something, this is not bad. Okay, sorry, wrong fit range. There you go. Or I can just like lower it. See, so if you want to create like a wall with, dirt or cement in the middle, this is a pretty decent way to go about doing that. So if I come to this box and let's say if we take this and flatten it, and I can just, try to increase that. Yeah, see, there you go. So this kind of modeling, which is, you could try and model this, but doing it with VDB becomes, much more better or simpler actually. Okay, and then we can come to this one and try to adjust it. And maybe, now see, you can like, what happens with fit range clamped is that you start seeing this value on the inside, where it sort of clamps it down to that level. So what you can do is, like, if you don't want this, stuff, then we can try to adjust the destination minimum or maximum. See, so that sort of pushes it in more if you want that. See, like if I take it all the way up to 4, then the internal wall disappears. But now it's like, there's no wall. It's just like completely hollow, like that. So I can keep it around 2 or something, which is fine. But yeah, the problem with doing clamping on it, or doing like a fit range clamped, you get, these issues. So you kind of just adjust it the way you want to. What you can do with something like this is, let's say if you made a wall like that, which is pretty nice and detailed. Let me just give it a little more smoothness. Yeah, okay. And let's try to increase roughness a little bit. Yeah, and what you can try to do after this is, like, if this is a piece of geometry that you like and you want to use it somewhere, you can try to do it like a standard baking procedure, right? Like, so let's bring it down to 0.006, which will give me, enough detail on it. See, there you go. So that's enough detail. And then what I can do is, after I convert it, I can try to do like a poly reduce. Like, one of the things you can do is you can come in here and you can adjust adaptivity. So if I make it like, say, 0.001, see, that will allow you to reduce the polygon count. You can also adjust the ISO value, which will sort of push or pull in the geometry. So if I just, keep this here, and again, if I make it 0.1, it will sort of expand out. And if I make it, minus 0.1, it will go inwards. But sometimes it will go in so much that it will just disappear completely. Like if I go to minus 0.5, it just disappears. So you have to be, sure how much you want to push it. Yeah, see, so you can do this, which isn't bad actually. Okay, and then what I can do is I can try to do a poly reduce on this. Yeah, so let's see if we can, like, bring this down. Yeah, let's try something. Let's keep this to 0. So it's more uniform. And let's bring this down to 5%. Yeah, I think this is good. Yeah, that's 34,000 polygons. okay, which is decent, like, or I don't know how low do you want to go with this. Yeah, okay, this looks terrible, but okay, let's try to do something. Let's give it some normals, and we can call it face area and lower that. And then what you can try to do is, like, once you have this, which is decent for some game work if you want to, and then you can take the original and then you can, like, you know, bake the details. So you can take this and that one, and then you can use the baking tools available in Houdini, or you can take it to like Substance Painter or something and bake it over there. So either ways, but it's a good way to add detail. So either ways, but it's a very good way to model this kind of stuff, like what you can't do otherwise. Okay, another thing that you can do, which is a little tricky actually. So if you come into, let's take another volume warp. Okay, let's say if you want to project a texture onto this, right? Like these are noise maps, but what if you have like a wall texture that you want to project onto it? So what you can do is, I'll just take this into a different, this thing. What's my resolution? Okay, let's keep this to 0.02. And let's say I want to project a texture. So what I can do here is I can take a texture, and what you want to do is in the UV, you project the bounding box. So take an add, and this is, it's default using like the mandrel image. So I'll keep it to mandrel. I don't have a wall texture at the moment, but, or let me just look for one. Okay, so I downloaded like a 1K texture from textures.com, like that's free. Okay, so I have this, like the whole thing looks like that, but we don't need the color data. So I just took this one. So what you can do is, I'll come in here and I'll load up that texture. And let's turn this into luminance, so we'll turn it to black and white primarily. And then I'll put a multiply constant in the middle. I always do this. And then you can't plug position into it. Okay, so what you want to do is you want to connect the bounding box. Okay, so connect bounding box to UV and then plug it into the add. Okay, and there you go. Okay, so just lower this till it looks okay. Okay, and I think we need to reverse it. So let's try to do a complement here, see if that works. And there you go. See, so you can take like an exterior, so you can take like an external file and then work with that. And the thing is it sort of projects from both sides. Okay, so if you want the backside to be flat, what you can do is you can try to do like a boolean. Okay, or you can do like a VDB boolean. Okay, so what I can do is I can take another box, and let me just adjust this. So I'll just keep it there and convert this to VDB. And what you can do is take a VDB combine, and we can do a boolean. So come in here in VDB combine and then just change this to SDF difference and say it'll like boolean this for you. So if you want to do that, okay, or if you want like the sides to be completely flat, you can do those kind of things with it. But like right now it doesn't matter, so it's not important. So you can do stuff like this, which is also useful. Okay, but what you can also do along with this is if we want to add like additional detail onto this, we can add like a noise map to this. Okay, so what I can do is, let's duplicate this guy, Control C, Control V. And I can take another, let's pick up a turbulent noise. And I'll take the position and plug it in there. I'll put a fit range in the middle because I don't want it to be, like unclamped. So we'll put a fit range. Let's change this to sparse convolutions. I'll drop this and we'll plug it into the add. And see, so what you can do is if I come in here, we'll increase the frequency. So one of the nice things about this is that it's very good for, you want to create like actual damage onto your, geometry or something, you can actually do that with this. And then I can come in here and you can define like how much it should affect. See, so I can actually like come in here and, if you wanted to like cause more damage to this overall, let's try to do this with like a fit range unclamped and see what we get. Yeah, see, that's the problem with the fit range unclamped. It just immediately sort of explodes. Okay, so a fit range clamped is a better option. But yeah, so if you want to take this wall and then, you want to break it further or something, Okay, like this is a really good idea. This is a good way to do it. And then you can try to offset it if you want. See, there you go. See, so you can like, completely eat it up that way if you want to. Or if you just want like a little bit of damage, we can do just a little bit of damage. Like I can come in here and then let's lower this down to about 5. We might not, yeah, we don't need it to be like, unless, as I said, like the only time you want to expand the exterior band voxels is if you're getting clipping. Okay, if you're not, then you can keep it low because it will calculate faster. Okay. And let's bring this down to 0.007. So you'll get, see, there you go. So this is like pretty fancy. You get a lot of detail on this. And then I can try to, adjust it or eat it up a bit more. Yeah. Or as we were doing before, let's see if we can like, yeah. So you can do this. And then what you can do is once you convert it to polygons, the one thing that happens is because this is working in like full 3-dimensional space and it's not just displacement, you will end up getting a lot of like floating pieces. So what you can do is once you convert this to polygon, yeah, the ISO is a problem. You get something in the lab tools called, type in like delete, and you'll get something called lab delete small parts, and just turn on extract largest piece. So what that will do is it will just leave you with just, the main geometry, and all the smaller pieces will disappear. Okay, like, so whatever is connected is what is kept and everything else will just go off. So when you want to do things like these, VDB is, your best friend. Okay, so that's pretty much it. This is not a very complicated lesson. I just wanted to cover, because the previous lesson was almost like 45-50 minutes when I was recording it. So I didn't want to, further add VDB into it. That's why I decided to split this into a second lesson. But once we start modifying and distorting noise maps, we'll start looking at VDB again, because you can do some pretty fancy stuff with it. Because it does like 3-dimensional, modifications to geometry, you can do some pretty interesting things. Okay, like another thing that you should remember with VDB is because you can do damage like this, you can also add damage to, existing models. So if you just want to do something like that, it's really good. Like if I take, I don't know, what do we have? Like if I take some test geometry, okay, let me just see. Like let's say if we take the test shader ball, okay, which is fine, and then I can, yeah, let's do one thing. Let's just check what this is like. Okay, I'm going to delete the material altogether. So let's take a, not that it's necessary because it's not going to remain there anyways. Once we convert it to, we can do like delete material shop. Okay, so we'll do VDB from polygons. Like if this is separate pieces of geometry, what my suggestion would be, like try to do a Boolean. That might be a better idea first, so that it can just combine everything together. Okay, like let's just see. If I go into 4, okay, let me just take an edit node. It's just not selecting anything in the viewport, which is weird. Yeah, these are all separate pieces of geometry. So let's do one thing. Let's take a fuse. We'll just fuse everything together. Because otherwise what happens is, like if they're not fused together, VDB will cause issues. So you have to make sure that everything is fused together. Let's try to do a subdivide on this so we know that it's all fused together. If we get open spaces, that means we have a problem. Yeah, I think it's good. Okay, so we'll fuse it. Another way to do it is you can try to do like a voxelize, but I'll do that in another lesson. Like right now this has worked, so it's fine. So I can take a VDB from polygons and then we can, convert this. Or let's do a subdivide first. Why not? Like we'll take a subdivide so it's slightly rounder, and then come into VDB and make it 0.01. There you go. Okay, let's try 0.001. Whoa, okay, that might be a little too high. 0.005. Okay, so for now we'll keep it to this, and then I can just keep it to density, and we can take a volume warp And the same thing, so we can just do an add here, and I'll just plug this in directly. Yeah, see, this is what happens. So you want to like make sure that you kind of adjust it. Wow, okay, so it just ate it up completely. Yeah, so this is again an issue, right? So make sure you turn on fill interior, because that's your problem, because we didn't have fill interior on. And also let's just take this up to 8. So what you want to do is let's increase the frequency a bit, and then I'll take a fit range, so we can just clamp out areas. Let's also do let's keep this to original Perlin. Yeah, there you go. See, so if you want to model like realistic rust or stuff like that, like things have actually corroded and not just do a textural thing, this is really good for those things. Okay, so I can then just take this and probably increase it and just adjust it accordingly. Okay, so I can just take this, and where are you? Okay, wow, this is like working in very small values, but there you go. And you can just adjust it like how much you want. See. So yeah, if you want to do stuff like this, where you actually want to model something and then just have it completely be eaten up or destroyed, then this is a very good way to go about doing it. Okay. So let's bring this down to 001 just to see it like in full detail. Yeah, there you go. See. So things you couldn't do otherwise. Yeah, because see, this is the thing, right? This is the difference between the displacement and VDB, is that so like this is fully 3-dimensional, right? Like it is actually like you can see these arcs going here. With displacement, it would just go up and down, so that's a huge difference. So again, like this is definitely not like game friendly or anything like that. Like if I convert, this is going to be very huge in polygon count. So if I change this to polygons, yeah, this is how much is this? Yeah, that's 3 million polygons. Okay, so definitely not user friendly, but let's say if I make it 0.05, that will reduce it for me. Yeah, there you go. See, so this is 600,000 polygons. Okay, so you can control it and reduce it. But yeah, always make sure that at the end of it, you should try to put in like one of those delete small parts, okay, because it will clean it up. Like you might get floating pieces here and there, so it'll just oh, okay, that was hollow. Yeah, don't do that. Like in this case, don't do that. Okay, we didn't need the separation. But there you go. So this is another thing that you can do with VDB. Okay, so the next lesson we'll take a look at how to modify and distort noise maps, and then we'll do more stuff with VDB.